desktop with
Recording started.
I'm going to my desktop because take you to MyLabs Plus when we get to the graphing section, because I have a lot of students ask me about graphing, and you can see the graph right there from MyLabs Plus. So I just, when we get to it, I want to walk you through some graphing examples, or just maybe one, show you how to graph a line in MyLabs Plus. It's if you miss a couple of steps, then it can be a little on the tricky side. So this is our third webinar for Math 100 on graphing and writing linear equations. You maybe have not gotten through some of the homework assignments for Module 9. But Module 9 it covers is linear equations, which means equations whose graph, when you graph it in the coordinate plane, is a line. And so there's a lot of things that we can learn about linear equations and writing those equations. Now let's talk about forms of linear equations in algebra. There are several different forms. There's probably more than just these three, but anyway, these are the base forms that you can write your linear equations in. And we don't do a whole lot with standard form. Just to recognize it, maybe a couple of questions in one of your homework assignments that have what form is this linear equation in. Standard form usually is when your x and y terms are on one side and your constant number is on the other. And there's no common factors, and your a is not negative usually as a rule. So here's an example of an linear equation that's in standard form. We see the 3x plus y is on one side and the constant number 5 is on the other. And then slope-intercept form. This is the primary form that we're going to be looking at. In fact, when you go to write linear equations, every single time, I mean, unless they're asking you to put it in a different form, but if it says write a linear equation for a line with this slope and this y-intercept, you will put your answer in slope-intercept. Now be careful, MyLabs Plus is not consistent in their answers. Sometimes they want you to put the higher equation, y equals m, where m, where that coefficient of x is the slope of the line, And then the constant number, including the sign that immediately comes before it, that's where that line crosses the y-axis, and that's called the y-intercept. So that's why this form is called slope-intercept form, because when you solve a linear equation for y, you have just one y, or y equals, and then you have your x term, and then you have a constant number. Then you can very readily, quickly identify your slope, identify where that line crosses the y-axis. So in this example, y is equal to negative 3x plus 5. It's the same equation as this one that's in standard form. Now we've put, and in fact, these are the same lines, so if you would graph both of them, you're graphing the same line. It's just in a different form. We see here that the coefficient of x is negative 3. I know that this slope line has a slope of negative 3. That means it's going to travel down pretty steeply from left to right in the coordinate plane. And then I can readily identify that this line crosses the y-axis at positive 5 on the y-axis. So when your equation is in slope-intercept form, you can tell very important things very quickly about the line. Now, the last one is point-slope form. This is a utility. I call it a utility form of linear equation because it's like the middleman. Given certain information, you're asked to write an equation for a line. You can use this point-slope form if you know the slope and at least one point that lies on the line. Again, that is your slope. That's the slope of your line. That's your slope. And then if you know another point that's not the y-intercept, another point, just say that point has an x-coordinate and a y-coordinate. If the slope and one point that lies on the line, you can put pieces of information into point slope form. Okay? So I've given you an example here. This, again, the slope is -3. The slope is -3. And then the point here, because we're subtracting the x and the y, the point that it goes through is the point 1, 2. Here's the 1 and here's the 2. Remember, in point slope form, you're going to subtract the y coordinate, and in parentheses on the right, you're going to subtract the x coordinate. So be careful of your signs. All right, let's put these into practice. We're going to talk about we graph linear equations given a certain algebraic equation for a line, okay? And the first method is by completing a table of points. Now, I get questions all the time. Okay, I can complete a table if you give me x values. Well, sometimes you'll be given x values. Some will just need to choose your own, and you're not wrong in whichever values you choose. Now, I tend to go with just something very, very simple, like I'll choose -1 probably. And I always want to choose 0 because that's going to tell me where my y-intercept is. And I'll choose a positive. Let's go with +1. So if -2, 0, and +2, you're not wrong. You're going to end up with 3 points that lie on this line, and then you'll be able to graph the line in the coordinate plane. All right, so how do we do this? Now that we've chosen our x values, how do we do this? Well, remember, the x and y values will make this be a true equation, okay? So we've got to plug in our values for x in place of x in the original question, and then simplify this expression because that's going to tell us what y is equal to when x is that value. So let me just show you. All right, let's say that x is -1. X is -1. So what is y equal? X is -1. So what I'm going to do is put -1 in place of x in my original equation and simplify, and that's going to tell me what y is equal. So -4 times -1 gives me a +4 1 and equal 5. So when x is -1, y turns out to be 5. I have my corresponding y value when x is -1. And we do that for each of the given values for x. I'm going to plug in now what happens to y when x is 0. So x is 0, I need to plug in 0 in place of x in the equation, and it's going to tell me what my y is equal to. So -4 times 0 is just 0, down to +1, and equals 1. So when x is 0, then y is 1. Let's do more. What happens when x is 1? When x is 1, we're going to plug in that 1 in place of x in the original equation and simplify that. -4 times 1 is -4. I'm going to add 1 to that. So that gives me -3. So now I know that when x is 1, was -3. So all of these points that you have found are points that lie on this line. So now we only have to graph. When MyLabs Plus, you really have to graph 2, and then it plops the line in. But let's just say, for the sake of doing it with pen and paper, we're going to graph these points, okay? So I'll go -1x and up to 5 on the y-axis, and that's where the first point is, right there. All right, let's graph the second point, 0, 1. That's going to be where the line crosses the y-axis at 0, 1, right there. And then the point 1, -3 is right there. Now, if I could draw a straight line on this computer tablet, then that line would drop right through all of those points. That's a big if, because I can't draw a straight line on this computer tablet, but use your imagination. All 3 of those points are supposed to lie on this line if my line were straight. So that's how you would graph a line using a table of values. Again, choose very simple values, plug in place of x, and solve for y, and you'll get some points that lie on the line, and then you'll be able to graph that line. Now, the second method of graphing a linear equation is by plotting the intercepts. That is where the line crosses each axis, okay? The x-intercept is where the line crosses the x-axis. The is where the line crosses the x-axis, and on the x-axis, y is equal to 0. Y is equal to 0. Now, take great care when you're doing your homework and completing your quiz this week. Take great care to read the instructions and figure out how they want you to graph the line. If they want you to graph it completing a table of values, you have to graph the line by completing a table of values. If it says graph the line by plotting the intercepts, then if you don't plot the x-intercept and the y-intercept, even though you plot the correct line, MyLabs Plus will mark you incorrect because the instructions said to plot the intercept and graph the line. All right, so the x-intercept, where the line crosses this horizontal x-axis and y is equal to 0. So how do we find the x-intercept? Well, we plug in 0 in place of y and solve for x, because that's going to give us the point. Remember, intercepts are points, the point at which that line is going to cross the x-axis. So I'm going to just do that. I'm going to put in 0 in place of y and solve for x. So 2 times 0 is 0, so that's negative x is equal to 8. So I have to multiply both sides by -1 to give me what x is equal to. So negative x is equal to 8, then x is equal to -8. So my x-intercept is the point -8, 0. Now the y-intercept is where the line is going to cross the y-axis. And at that point, and we've seen this, that is where x is equal to 0. That just goes away, so 2y is equal to 8. And so divide both sides by 2, and we have y is equal to 4. So the y-intercept, where x is equal to 0, is 4. Now let's plot this 0, 4 on the y-axis. Here's my y-intercept right here, and I'm doing x because with this pen, if I do a circle, it disappears for some reason. So I'm just doing an x. My x-intercept, where this line is going to cross on the x-axis, right here at -8, right here. So I can drop this line in now that I have graphed or plotted the intercepts. This is what you're going to do in MyLabs Plus. You're going to plot the intercepts, and then MyLabs Plus will automatically drop this line in for you. You don't have to freehand it. Right, so graphing the intercepts, the x-intercept is the point where the line will cross the x-axis and y is equal to 0. The y-intercept is the point where the line crosses the y-axis and x is equal to 0. To find the intercepts, you just plug in 0 in place of the other variable and solve for whichever intercept you're trying to find. Okay, the third way is to graph line using slope-intercept. Now remember our slope-intercept form, linear equation, y is equal to the slope times your x, your slope times your x, and plus your y-intercept, okay? So this is the form to re-identify your slope and your y-intercept. So the first thing you want to do before you can graph this is to make sure your equation is indeed in slope-intercept form. This is not. This happens to be in standard form. So in order to put this in slope-intercept form, I need to subtract 3x from both sides. Y is equal to minus 3x plus 5. Now I have my equation in slope-intercept form, and I can readily identify my slope, which is the coefficient of x, so my slope is 3. Now remember, slope is the ratio or the comparison of y is changing to how x is changing, okay? So your slope is how is your y changing compared to how your x is changing. Sometimes people say, how does the line rise up and down compared to how does it run? Okay, so sometimes when you're graphing and you've got a whole number for a slope, we want to put that into rise over run form. So we're going to say that that's negative 3 over 1. That way we can easily figure out how much we have to rise and how much we have to run. Now remember, this is a negative slope. Negative slope lines descend from left to right. They go down from left to right, okay? And this is going to tell us how far it goes. Now your y-intercept is plus 5, but the point, your y-intercept is plus 5, but we want to graph that point. Remember, the y-intercept is where x is equal to 0. So y-intercept is the point 0, 5. So let's go ahead and plot that first. Okay, plot your y-intercept first. When you're graphing a line using slope-intercept, you want to plot your y-intercept first. Now we're going to use the slope of negative 3 or negative 3 over 1 to find the next point on the line. I can go either, now remember, negative 3 or negative 3 over 1, you can either have the negative be in the numerator or the negative be in the denominator to make the whole value negative. So I say that because you can either run in a negative fashion from the y-intercept, which would be going down 1, 2, 3 units, and then run in a positive 1 direction. I don't know why lines keep disappearing. And then run in a positive 1 direction, and here's your second point. Or you could rise positive 3, which is going to take me off the graph, 1, 2, 1 more unit off the graph, and then run a negative 1. You go negative 1 on the x-axis, and your point be right here. Either way you choose to do it, it should lie on the same line. So all these points are going to lie on the same line. So when you are using slope-intercept, the first thing you're going to want to do is to plot your y-intercept point first. And use your slope, rise and run, find the next point, and then your line will be drawn. Now let's see how we graph a line in Labs Plus. Let me pull this thing up real quick. Okay, let's graph this line right here. This is part of the homework, 17.1, and it's asking us to graph the line y is equal to negative 4/3 x minus 5. So I said the slope is negative 4/3, and my y-intercept is this at minus 5 on the y-axis. Right, so here's the graph they've given us. Make sure before you graph that you click this magnifying glass in the upper right corner. That's going to give you a pop-out window, just like this. It's going to expand your graph for you, which makes seeing the lines just a little bit more easy. All right, so to graph a line, you're going to choose your line tool. Okay, and this is the palette over here for graphing. We're not going to do a whole lot with circles or parabolas or anything like that this class. You're going to choose your line tool, and when you click on the line tool and go move the mouse around your graph, you're going to see dashed lines, a vertical dashed line and a horizontal dashed line with a gray dot in the middle. That's that gray dot that you want to move around to your y-intercept. Remember, the point, the y-intercept is at -5 on the y-axis. So that's the first point I need to graph. So I'm going to drag this dot to -5 on the y-axis, and I'm going to click because I want to put that dot there. So I'm clicking. The line is going to be anchored right to that -5 on the y-axis. Okay, and that's when you've got another gray dashed vertical and horizontal line, but it's dragging this blue line around. Okay, now see the gray dot. You want to find the next point that lies on the line. Okay, let's go back to our y-intercept. Our slope is -4/3. Now remember, I said we could, since it's negative, we could either rise negative 1, 2, 3, 4, and run +3, 1, 2, 3, and I would pop that dot right there. Okay, or you could rise in a +4, run -3. But let's just, for the sake of plot this next point, let's rise -4. That means go down 1, 2, 3, 4, and run 3 units positive 1, 2, 3. All right, that's the next point I need to plot. So I'm going to click, and there's the line that I just graphed. Okay, now I'm going to make sure that that's exactly the line that I want to graph. If it's not, I can click on this clear button and it will make my line disappear. If I want to save it, because I'm pretty sure that this is correct, I'm going to click on Save, and then that pop-out window will disappear and your line will be graphed on the problem page. Okay, you still at this point have the option of saving it and moving on, checking your answer, or saving it and moving on. Or if you're like, wait a minute, that line I don't think is right, you can clear it by hitting this clear button and it will disappear. Okay. Now notice our slope is -4/3, and this line travels downward from left to right in the coordinate plane. Then you know your line at least corresponds to the negative slope. A negative slope line will always be angled down. Let's move back to our PowerPoint presentation, and let's look at vertical and horizontal lines. They're a little bit different because you see this equation doesn't have an x equation. It's just y is equal to a constant number, and this constant number happens to be -3. We can look at it the same as y is equal to, have any x's, 0 x's -3. So it doesn't matter what value you would put in place of x, y is always going to be -3. So x could be 4 and y is still going to be -3. X could be -10 and y is still going to be -3. Why? Because with 0 x's, and 0 times any number is 0. So that's the reason why a horizontal line is when y is equal to a constant number. And I can't draw a straight line. Please excuse me. So it should be a horizontal line right at y is equal to -3. Doesn't matter what x is, y is always going to be -3. So what happens when we only have an x in the equation? No y. Well, first, let's just get our variable alone by adding 5 to both sides, and an equation that we can work with. So when I add 5 to both sides, I find that x is equal to 2. There are no y's. There are 0 y's. And so it doesn't matter what y is. X is always going to be 2. X is always going to be 2. It doesn't matter what y is. So this is the equation for a vertical line. When x is a constant number, you have a vertical line. Sorry for the not straight line. If you have 0 y's in your equation, no y's, then you know your line will never cross the y-axis. It's always going to be parallel to the y-axis, okay? So if x is your only variable in your equation, you have a vertical line. If y is the only variable in your equation, y is equal to -3, then you have no x's. It's never going to cross the x-axis. It's going to be parallel to the x-axis, and you have a horizontal line. Now, how do we find slope? The slope of a line is just how it's angled in the coordinate plane. In other words, the slope of a line is how is y changing, and that delta symbol just means the change in y compared to how x is changing as the line travels through the coordinate plane. Now, from a graph, if you've got 2 points on a line that's given, you want to travel from one to the other, okay? First, we want to travel the y's, okay, from one y to the next point. So we're going to travel, we'd have to go up 1, 2. I'd have to go up 2 units to get from one point to the next. And then I'd have to travel right, so +1. I went from this lower point to the upper point. So I know that my slope is 2. You can figure out slope between points on a graph without using any kind of formula. Just travel from one point to the next, going up first to find out how your y is changing, and then travel left or right to that next point to find out how your x is changing. And always simplify your slope, okay? I could have left this as 2/1, and value-wise that is correct, but it's not in its simplest form. 2/1 is just 2. What if we just know the points and we don't have the graph? We're just given the points, -2, -1, and 1, 1. We have this graph. Well, again, remember slope is how is y changing compared to how x is changing. So what we want to do is using the y values in my point given, I'm going to just subtract them because the change in y is just the difference between the y coordinates. So I'm just going to put, and it really doesn't matter which one you call point 1 and point 2. Okay, it doesn't matter as long as you keep your signs correct. It doesn't matter if you start and call this one point 1 and this one point 2, or you want to call the first one point 2 and the second one point 1. It really doesn't matter as long as you're consistent. So let's look at this. Let's just leave this as is. So I'm going to subtract the y values of my points. So the y value of point 2 is 1. I'm going to subtract the y value in my first point, which is -1. I need to subtract -1. Then I've got to go back and select my x-coordinate from point 2 and subtract the x-coordinate for point 1. That would be a -2. We're subtracting a negative. Now remember, now you're just going to simplify, but remember, when you subtract a negative, the two minus signs together become one plus sign. So really, you're saying 1 minus a -1, it becomes 1 plus 1. Same thing in the denominator, you're subtracting a -2, so -1, -2 becomes plus 2. The numerator is just 1 plus 1 or 2. The denominator is -1 plus 2, which is +1. Simplified, my slope is 2. And I think that's what we found because they're the same, it's the same line. Okay, this is your slope formula. If you have 2 points, just be careful. If you're subtracting negative coordinates, subtract negative becomes adding. Okay, so just take care of how you deal with your signs. Now, writing linear equations. This brings us into just everything that we've talked about up to this point, you're going to use when you write a linear equation. Okay, the first scenario is you want to write an equation of a line if you know the slope and know the y-intercept. Well, this is very basic because I know the slope-intercept form is y is equal to the slope times x plus my y-intercept. So basically all I'm going to do is plug in my slope of this particular line, which is 3, in place of m in my slope-intercept form. And then I know that the line crosses the y-axis at 0, 5, so this 5 is where it crosses the y-axis, and that's going to be my plus b. So the equation for this line is simply, it's just like a puzzle, is equal to, plug in my 3 plus, since 5 is positive, plus 5. And it's just simple as putting these things in the right places in your slope-intercept form of linear equation. Again, what happens if we have a graph? Well, all we need are need to know two things in order to write a linear equation in slope-intercept form right away. We need to know the slope of the line, and we need to know where does that line cross the y-axis. Okay, so the first thing I can see is the line clearly crosses the y-axis at the point 0, -2. So my plus b in my equation is going to be actually -2. All right, let's just write my slope-intercept form. Y is equal to my slope times x plus y-intercept. Okay, now remember how we found slope between points just a little bit ago? We're going from one point to the next. Now you could actually get the coordinates of these 2 points and use your slope formula and algebraically figure it out. But from a graph, you can just travel from one point to the next. I see the line is angled up in the y-axis, in the coordinate plane, so my slope is going to be positive. So I'm going to rise 1, 2, 3, 4, 5. So I'm going to rise positive 5 compared to, well, I just lost my slide. Fix this. Please excuse me. I'll figure out what I did here. All right, I'm this presentation back up. Hi, guys. I think I can, and it didn't like it. so, all right, here we go. See if we can't figure this out again. I think we already figured out our slope. Now, working on our slope, but we knew that our plus b was at -2. I'm calculating our slope between the 2 points. So here, hopefully I won't click that button again. For rise, I think it was positive 1, 2, 3, 4, 5 from one point to next, plus 5. And then we're going to run 1, 2, 3, 4, and we're at the next point. So run 4. So slope is 5/4. All that we know, the slope and y-intercept, we just plug those values in our formula for slope-intercept form. And here's our slope, 5/4 x, y-intercept, y-axis at -2. Okay, that's the equation for this graphed line. I think there is a couple more, and then we're done. This is where we get to use the point-slope form. If you're asked to write a linear equation given the slope and point that is not the y-intercept. Here we know that's not the y-intercept because x is not equal to 0. So if we know the slope and one point that lies on the line, we can use this middleman point slope form to plug in the specific values, and then we solve the equation for y and put it into slope intercept form. So here is the slope. That's where my slope goes. So in this example, that's -1/2. And then the point is -6/4. So I know that my -6 goes here, because x value of my point right here. And then 4 goes right here, where the y coordinate of my given point is. So let's put this all together. Y minus the y value of my point is equal to the slope, -1/2. And these x, that's just your general x for your linear equation, minus the x value, which is -6. Now, simplify. We have two negatives here together, so we're going to simplify that and make it a plus. So -4 is equal to -1/2 times x plus 6. Distribute and simplify this equation. Distribute the -1/2 through to each term inside parentheses. So -1/2 x. And then -1/2 times plus 6 is going to give me a -3. We're going to put this into slope-intercept form by adding 4 to both sides. Remember, slope-intercept form is when you've got your equation solved for y. So y is equal to -1/2 x plus 1. All right, you can use point slope form when you're given the slope and one point that's not the y-intercept, point that also lies on the line. Now, one more scenario before we close. What happens if we don't have any slope, but we're just given 2 points, and we're asked to write an equation of a line that goes through those 2 points? Well, remember, the 2 things that we need to know in order to write a linear equation, the first thing we should know, given 2 points, we can figure out what the slope is. Remember, the slope is the change in y, or the difference in the y values compared to the difference in the x values. So if you have 2 points, you can figure out your slope. So we're going to put these into, remember, we're going to subtract. These all just mean the same thing. We're going to subtract the y coordinates and compare that over the difference in the x's. So let's call this point. Let's be different. Let's call that point 2. We're going to call this one point 1. So I'm going to subtract y values. So the y value in the second point minus the y value in my point 1 compared to the difference in the x's. So 5 minus a -3. Again, subtract negative, you're really adding. 5 plus 3. And this works out very nicely, 8 or 8, so my slope is 1. That was a long way to say the slope is 1. Now I can use my middleman, my point slope form, since I know my slope now is 1, and now I've got 2 points to choose from to put into point slope form. So it doesn't matter which point you choose. Well, I guess this is 1. Let's choose point 1. You could put point 2 in and should still end up with the same equation. All right, so let's let me choose a different color here. Know my slope and point that lies on the line, so I'm going to subtract my y value of that point. That equals my slope of 1. I'm going to subtract the x value of that same point. I'm going to simplify. Y plus 2 is equal to, now I don't have to use that 1 because 1 times anything is just itself, x plus 3. Now to solve for y, I'm just going to subtract 2 from both sides. So y is equal to x plus 1. And that's the equation of the line is between these 2 points that run through these 2 points. I hope this has been helpful. Again, I'm sorry for that technical glitch where my presentation disappeared, but worse things could happen, and I'm glad they didn't. So you are certainly welcome to contact your instructor for the link to this recording, since I went rather quickly through some of these. And please join us for our factoring. We'll be sending you a link to get registered for factoring here in just a little bit, in a few weeks or so. And let me try to stop sharing my desktop and let you guys go. If you have questions, please contact your regular instructor. Otherwise, I'll be praying for you to do best